To all my viewers, feel most welcome into our today's discussion, whereby this is now my second video on inverse Laplace transform after the introduction part. Here we are going to work out our example here directly. I'm not going to explain much. Let us now start our working, whereby now we are going to rewrite everything here, and it will be the inverse Laplace transform of s squared we add to 5, s we add to 11, all over s we subtract from 2, s we add to 3, s we add to 4. Everything is going to be equals to the inverse Laplace transform of a all over s we subtract from 2, we come and add to b all over s we add to 3, we come and add to c all over s we add to 4. Let us now use the partial fractions formula in getting the value of a, b, and c. And for us to get all those values, we must use the cover-up rule. So cover-up rule is going to help us get the value of a, b, and c. The cover-up rule is used in partial fractions, whereby now for us to get the value of a, we are going to take as we subtract from 2, everything will be equals to 0. And we are looking for the value of s. So we are going to have s will be equals to now a positive of 2. We come and say that, limits of s, limit of s approaching 2 into s squared we add to 5s we add to 11 all over. This is what we refer to as the cover up rule. We cover our term here for a, we cover it, and now we are going to have s plus 3 into s plus 4. So that is what we refer to as the cover up rule. We come and cover up our first term here, and it is only applicable to the linear equation of first degree, not second degree. It is only applicable to linear equation of first degree. Now here we are going to insert our limit, because we say that the limit of s approaching a positive of 2. So we are going to have, where we are having s, we replace with the 2, and here we are going to have 2 squared. We come and add to 5. 2, we add to 11. All over 2, we add to 3. And now s we add to, 2 we add to 4. On our numerator, we are going to have 4. We add to 10. We add to 11. All over. On our denominator, we are going to have 5. And here we are going to have 6. 6, yes, 5. When we add our numerator, we are going to have 25 all over 30. 5 can go here 5 times, 5 goes here 6 times. To mean that the value of A now is going to be 5 all over 6 when we simplify our function there. Let us now use the cover-up rule to get the value of B. For us to get the value of B, we say that we come and get the partial fraction of B, where B will be S we add to 3 is equals to 0. To mean that S will be equals to a negative of 3. Let us now use the cover-up rule to get the value of B. We are going to have limit S approaching a negative of 3 into S squared, we add to 5S, we add to 11, all over. We are going to cover up this term S plus 3, and here we are going to have S we subtract from 2 into S we add to 4. That is what we refer to as the cover up rule. We block this one and use the rest of the function. And now here we are going to have negative 3 squared, because we said that it is the limit we insert to the term of S where S approaches negative 3. We come and add to 5 into negative 3. We come and add to 11 all over negative 3. We subtract from 5 into negative 3. We add to 4. On the numerator, we are going to have 9. We subtract from 15. We add to 11 all over negative 5. And here we are going to have a positive of 1, which is equals to just negative 5. Here now we are going to have 5 all over, on the numerator we are going to have 5 all over negative 5. To mean that the value of B now is equals to a negative of 1. This was the value of A, the value of B. Let us now use cover-up rule to get the value of C, whereby we are going to have C S is equals to 0, whereby S will be now equals to negative 4. We are going to use the cover-up rule, whereby we are going to cover up this term. And by covering up this term, now we are going to have S squared limit first S approaching negative 4, S squared, we add to 5S, we add to 11 all over. We are going to cover up this term, and now on our denominator we are going to have S we subtract from 2, we come and have S we add to 3. Everything will be equals to, because we have our limit S approaching negative 4, here we are going to have negative 4, everything squared. We come and add to 5, we multiply by negative 4, we add to 11, everything all over negative 4, we subtract from 2 all over into, negative 4, we add to 3. Here we are going to have 16. We subtract from 20, we add to 11. All over. Here we are going to have negative 6. We multiply by negative 1. On the numerator, here we are going to have a positive of 7. All over, have a positive of 6. The value of C now, C will be equals to 7 all over 6. We've worked out the values of A, B, and now C. Let us now get back into our working, whereby we are going to replace the value of A, B, and C, and then lastly we do the inverse Laplace transform of each and every function. Let us now get back into working the Laplace transform. We agreed that the inverse Laplace transform of A all over S, we subtract from 2. We add to B all over S, we add to 3. We come and add to C all over S, we add to 4. We have the values of A, B, and C, and we are going to replace them, whereby the value of A now is equals to what we got here. At this point, I'm going to have now 5 over 6 to be the value of A that I got using the cover up rule. The inverse Laplace transform of now all over S, we subtract from 2. Let me rub it. B, the value of B was negative 1. All over S, we add to 3. We come and add the value of C is 7 all over 6 all over S, we add to 4. Now we've replaced the values of A, B, and C. Let us now have the inverse Laplace transform of each and every function here. We are going to have 5 all over 6. The inverse Laplace transform of 1 all over S, we subtract from 2. We come and add 2. Here we are going to have a negative of 1. The inverse Laplace transform of this negative is the one that is going to affect the positive that we are having there. 1 all over S, we add to 3. We come and add to 7 all over 6. The inverse Laplace transform of 1 all over S, we add to 4. Lastly, we agreed that using the first principle, whereby we say that the Laplace transform of exponential, positive or negative, at is equals to 1 all over S, negative or positive of A. In the previous video, using the first principle, we derived that exponential, positive or negative at is equals to our function here. To mean that when we come and check whatever we are having here, we can relate to the exponential. Let us now come here. We are going to have 5 all over 6. When we are having a negative here, a negative of A, Here we are going to have exponential a positive of a. So here we are going to have 2t. We come and subtract from the inverse Laplace transform of this function is going to be exponential. We are having a positive to mean that we are going to take the negative of a, which is equals to 3. We come and add to 7 all over 6. The inverse Laplace transform, here we are having a positive, exponential, a negative of 4t. And this is how you go about finding the inverse Laplace transform of the function that we started working with.